Look up at the night sky and you'll see countless stars, swirling galaxies, and cosmic wonders, but none quite like the Hoags object. Imagine a perfect ring of blazing blue stars, floating like a celestial halo around a golden core, suspended in the blackness of space. This isn't some artist's rendering or a sci-fi fantasy, it's real. The Hoags object is one of the most bizarre and beautiful galaxies ever discovered, a cosmic oddity that defies everything we thought we knew about how galaxies form. And yet, as strange as it appears, the mystery only deepens when you peer closer. Scattered within this enigmatic ring lie 30 peculiar objects, each one more puzzling than the last. Some glow with eerie light, others vanish without a trace, and a few seem to defy the laws of physics altogether. What could these objects be? Are they remnants of a cataclysmic collision, or something far more extraordinary? For decades, astronomers have scratched their heads, piecing together clues that only seem to lead to more questions. The Hoags object doesn't just challenge our understanding, it throws it out the window. And today, we're going on a journey to uncover its secrets. We'll dive into the heart of this cosmic anomaly, exploring those 30 strange objects one by one, each with its own story to tell. From rogue black holes to star clusters that shouldn't exist, the Hoags object is a treasure trove of cosmic enigmas waiting to be unraveled. But here's the thing, this isn't just a story about distant stars and cold, empty space. It's about us. Every strange object we find, every mystery we solve, reshapes our place in the universe. The Hoags object forces us to question what we know, to look beyond the familiar and embrace the unknown. So, if you've ever stared up at the night sky and wondered what's really out there, this is your invitation to explore the unexplainable. Buckle up, because by the time we're done, you'll never see the cosmos the same way again. At the heart of the Hoags object, hidden within its radiant golden core, lies a cosmic monster, a supermassive black hole that refuses to follow the rules. Most ring galaxies have quiet, dormant black holes at their centers, like slumbering giants barely stirring. But this one, it's wide awake, crackling with energy in ways that leave astronomers baffled. Supermassive black holes typically feed on gas and stars, growing brighter as they devour matter in violent bursts. Yet the one inside Hoags object behaves differently. It flickers unpredictably, like a campfire that won't decide whether to blaze or die out. Some days it emits powerful jets of radiation, while other times it falls eerily silent. This irregular activity suggests something unusual is happening in its surroundings. Perhaps an unstable flow of material, or even the presence of a second, smaller black hole locked in a chaotic dance around it. What makes this even stranger is the black hole's size. Compared to other galaxies, Hoags object is relatively small, yet its central black hole is disproportionately massive. It's as if a tiny city somehow housed a skyscraper meant for a metropolis. How did it grow so large in such a modest galaxy? Some theories point to a turbulent past, maybe a collision with another galaxy funneled enormous amounts of gas into the center long ago, fattening the black hole in a single cosmic feast. Others speculate this black hole could be a primordial relic, a leftover from the universe's earliest days, when conditions allowed these monsters to form far more quickly than they do today. Then there's the ring itself, a perfect circle of young, blue stars orbiting at a safe distance. Normally, a black hole this active should disrupt such delicate structures, yet the ring remains pristine, almost untouched. It's like watching a tornado pass through a field without bending a single blade of grass. This contradiction forces scientists to reconsider how black holes interact with their galaxies. Maybe Hoags object's black hole isn't as destructive as others, or perhaps the ring is far more resilient than we ever imagined. Every clue we uncover only leads to deeper mysteries. Is this black hole an outlier, or does it represent a hidden class of cosmic anomalies we've overlooked? One thing's certain, The Hoags Object's heart beats to a rhythm we don't yet understand, and unlocking its secrets could rewrite what we know about how galaxies and their black holes evolve. But the black hole's strange behavior doesn't stop at flickering or unusual size. It also fires off jets of energy unlike anything astronomers have seen before. Most supermassive black holes launch twin jets of plasma, spewing matter at nearly the speed of light in a predictable, symmetrical fashion. Not this one. The jets from Hoags Object's core are erratic, twisting through space in uneven bursts, sometimes flaring to life on one side while the other remains eerily dormant. This lopsided activity defies conventional models of black hole physics. Normally, jets form when magnetic fields near the black hole's event horizon channel material into narrow, high-speed streams. But for that to work, the system should be balanced like water shooting evenly from both sides of a spinning sprinkler. So why is Hoags Object's black hole behaving like a broken fire hose, spraying energy in fits and starts? One leading theory suggests the black hole might be wobbling. Imagine a spinning top that starts to tilt. Its movement becomes unstable, lurching unpredictably. If the black hole's axis is shifting due to some past disturbance, like a close encounter with another massive object, its jets could be flickering as it struggles to realign. Alternatively, the disk of material feeding the black hole might be warped or clumpy, creating uneven fuel delivery that disrupts the jet formation. Then there's the wildcard possibility. A second black hole could be interfering. Binary black hole systems are rare but not impossible, and if one is orbiting close to the main one, their gravitational tug of war could distort the jets into these bizarre patterns. It's like trying to write smoothly while someone keeps jostling your elbow. The result would be a chaotic mess. Even stranger, these jets don't just behave oddly, they glow in unexpected ways. Normally, black hole jets emit radio waves and X-rays, but some of Hoags Object's emissions appear in ultraviolet frequencies, suggesting shock waves or interactions with invisible structures in the galaxy's core. One astronomer described it as hearing a song where the instruments keep changing tempo. Every time we think we've figured it out, a new note throws us off. These jets are more than just a cosmic curiosity, they're clues. If we can decode why they're so unstable, we might unlock secrets about how black holes evolve, how galaxies stabilize, or even how matter behaves under extreme gravity. For now, though, Hoags Object's central engine remains a puzzle. Its irregular heartbeat a reminder that even in the vastness of space, nature still has a few tricks up its sleeve. Surrounding the enigmatic black hole of Hoags Object, like a sapphire necklace flung into space, floats its most striking feature, a near-perfect ring of young, blazing blue stars. This isn't just any stellar formation, it's a cosmic masterpiece so precise it looks artificial. Most ring galaxies exhibit some warping or asymmetry, their structures distorted by gravitational interactions over time. But Hoags Object's ring defies expectations, maintaining an almost mathematical circularity that has left astronomers both dazzled and deeply perplexed. What makes this flawless ring so extraordinary isn't just its shape, it's the stars themselves. Blue stars are the universe's rebels, massive, hot, and short-lived, burning through their fuel in mere millions of years rather than billions. Their presence in such a concentrated, synchronized ring suggests a dramatic, recent event, a starburst so intense it birthed an entire generation of stars at once. Normally, galaxies produce stars gradually, with older red stars dominating the core and younger blue stars scattered unevenly along spiral arms. Here, though, the ring's uniformity hints at a single, violent trigger, like a stone dropped into a pond, sending ripples of star formation racing outward in a perfect circle. But what could have caused such an event? One leading theory points to a galactic collision. Imagine another galaxy, smaller and packed with gas, plowing straight through Hoags Object's center millions of years ago. The impact would have sent shockwaves through the surrounding material, compressing gas clouds until they ignited into stars. Yet if that's the case, why is the ring so symmetrical? Collisions usually leave messy, lopsided debris, not pristine circles. Some researchers argue the intruder galaxy must have hit Hoags Object dead center, like a bullet passing cleanly through a target, leaving behind a shockwave that propagated uniformly. Others propose the ring might be a self-perpetuating structure, with each new generation of stars triggering the next in a cascading cycle of birth. Even more puzzling is what the ring reveals about the galaxy's timeline. Blue stars shouldn't last long enough to form such a stable, long-lived ring. They should have exploded as supernova eons ago, leaving behind neutron stars or black holes. The fact that they haven't suggests the ring might be younger than we think, or that some unknown mechanism is continuously replenishing it with fresh gas. Observations reveal faint traces of hydrogen clouds drifting inward, possibly fueling new waves of star formation. It's as if the galaxy has its own cosmic conveyor belt, quietly feeding material into the ring to keep its blue heart alive. Perhaps the most tantalizing clue lies in what's missing. Between the golden core and the blue ring stretches a vast, dark gap, a no-man's land where stars are conspicuously absent. This void shouldn't exist under standard models of galactic evolution. Gravity should have pulled at least some stars into this transitional zone over time. The absence implies something is actively clearing the area, perhaps the gravitational tug of the central black hole or unseen dark matter shaping the galaxy like invisible hands molding clay. Hoags Object's ring isn't just a celestial oddity, it's a time capsule. Every star, every gap, every unanswered question holds a piece of the puzzle, waiting to reveal how galaxies defy expectations and rewrite their own rules. And as we unravel its secrets, we're not just studying a distant ring of blue fire, we're glimpsing the untold stories of how the universe builds its most stunning creations. The blue ring and golden core of Hoags Object might steal the spotlight, but the real cosmic heavyweight lurking in the shadows is something far more elusive, a vast, invisible cloak of dark matter enveloping the entire galaxy. While we can't see it directly, its gravitational fingerprints are everywhere, warping space itself in ways that defy conventional explanation. Most galaxies have dark matter halos diffuse, spherical clouds that extend far beyond their visible stars. But Hoags Object's halo isn't just massive, it's shaped all wrong, with a distribution so peculiar it challenges our fundamental understanding of how dark matter behaves. Take a typical spiral galaxy like the Milky Way. Its dark matter forms a smooth, symmetrical cocoon, densest at the center and gradually thinning outward. Hoags Object's halo, by contrast, seems lumpy, almost patchy, with unexpected clumps and voids that shouldn't exist. Computer simulations struggle to recreate this unevenness without invoking exotic physics. Some regions pull on surrounding stars with startling intensity, while others exert curiously weak gravitational influence, like invisible hands gripping some parts of the galaxy tightly while barely touching others. What could cause such bizarre fluctuations? One possibility involves ancient cosmic violence. If Hoags Object collided with another galaxy long ago, the gravitational turmoil might have stirred its dark matter like a spoon swirling cream in coffee, creating chaotic density variations that never fully settled. Yet there's no obvious debris from such a collision, no trailing stars or distorted gas clouds to support the idea. Another theory suggests dark matter particles themselves might interact in ways we don't yet understand. Most models assume they pass through each other ghost-like, but what if they occasionally stick or repel, forming invisible structures within the halo? Even stranger is the halo's alignment, or rather, its misalignment. The distribution of dark matter doesn't neatly match the orientation of the visible galaxy, as if the halo is tilted at an odd angle to the ring of stars. This contradicts the standard view that dark matter guides luminous matter into place, acting as a gravitational scaffold. Here, it's almost as though the stars and dark matter are ignoring each other, dancing to different cosmic rhythms. Perhaps the biggest puzzle is the halo's sheer size. For a galaxy of Hoags Object's modest stature, its dark matter envelope stretches improbably far, nearly twice the diameter of comparable galaxies. This raises provocative questions. Did it cannibalize smaller galaxies in the past, absorbing their dark matter? Or could this be a rare relic from the early universe, when conditions allowed halos to form with extraordinary dimensions? Every observation deepens the intrigue, revealing dark matter not as a passive backdrop, but as an active, dynamic force shaping Hoags Object in ways we're only beginning to grasp. One thing's certain: this invisible architecture holds the key to the galaxy's stability. Without its dark matter anchor, Hoags Object's delicate ring would have frayed into chaos long ago. Yet the very substance keeping it intact is also the source of its deepest mysteries, a reminder that the universe's most powerful forces often hide in plain sight. Between the glowing golden core and the radiant blue ring of Hoags Object stretches one of the most puzzling features in all of galactic astronomy, a vast, dark void where almost nothing seems to exist. This isn't just a quiet patch of space, it's a near-perfect cosmic moat, a pristine gap so devoid of stars and glowing gas that it looks almost deliberately carved out. If you were to fly a spaceship through this region, you'd find yourself in an eerie emptiness, with the blazing core on one side and the shimmering ring on the other, separated by a staggering gulf spanning tens of thousands of light years. What makes this gap so baffling isn't just its existence, it's the precision of its boundaries. The transition from core to void is razor sharp, as if someone drew a line in the stars and said, "Nothing crosses here." In most galaxies, gravity ensures that stars and gas gradually thin out from the center in a smooth gradient. But Hoags Object defies this expectation with an abrupt cutoff, a stellar desert that seems to actively resist being filled. So what's really going on in this forbidden zone? One leading theory points to gravitational clearing, the idea that the supermassive black hole at the galaxy's center, combined with the collective pull of the core's stars, has swept the area clean over time. Picture a cosmic game of billiards where the intense gravity near the core acts like a cue ball, scattering stars and gas outward, leaving behind an empty pocket. But there's a problem with this explanation. The gap is too clean. Gravitational interactions typically leave behind at least some stragglers, rogue stars, or wisps of gas that refuse to be pushed out. Yet this void remains stubbornly pristine, raising the possibility that something else is at work. Another compelling idea involves resonance, a phenomenon where orbital rhythms create dead zones. Just as Saturn's rings have gaps caused by the gravitational influence of its moons, Hoags Object's void might be shaped by invisible forces orchestrating where material can and cannot accumulate. Stars and gas that venture into this region could be funneled away by gravitational harmonics, like sand slipping through the grooves of a vibrating plate. Some researchers even speculate that dark matter might be the hidden conductor, its uneven distribution creating pockets where normal matter simply can't stay. Then there's the wildcard theory. What if the gap isn't truly empty? Instead of a barren wasteland, it might be teeming with objects too faint or exotic for our telescopes to detect. Black holes, neutron stars, or cold, failed stars known as brown dwarfs could lurk in the darkness, invisible to optical observations but still exerting gravitational influence. There's also the possibility of rogue planets, billions of worlds untethered to any star, drifting through the abyss like phantom ships. If so, this empty gap could be one of the most densely packed regions of the galaxy, just not in a way we can easily see. The most tantalizing clue lies in the rare, fleeting flashes detected in the void. Occasionally, sensitive instruments pick up brief bursts of energy, quick flickers of X-rays or radio waves that vanish before astronomers can pinpoint their origin. Could these be the death cries of stars falling into hidden black holes, or signals from some unknown astrophysical phenomenon? Each flicker is a breadcrumb, hinting at secrets the gap refuses to surrender. One thing is certain, this cosmic no-man's land is anything but accidental. Its razor-edged boundaries and eerie silence suggest forces at work beyond our current understanding, a reminder that even the emptiest corners of the universe can hold the most profound mysteries. Whether a gravitational artifact, a resonance phenomenon, or a hidden realm of invisible objects, Hoags Object Galaxy challenges us to rethink what it means for space to be truly empty and what wonders might be hiding in plain sight. Beyond the shimmering blue starbirth ring of Hoags Object lies another, far more mysterious structure, a lopsided outer dust ring that seems to defy all logic. While the inner ring dazzles with its perfect symmetry, this outer band of cosmic debris twists and warps unpredictably, like a hula hoop tossed carelessly into space. The contrast couldn't be more striking. One ring a flawless celestial bracelet, the other a drunken spiral of cold gas and dust that can't seem to decide which way to spin. This warped outer ring tells a story of cosmic violence, evidence that Hoags Object hasn't always been the serene anomaly we see today. The misalignment suggests a dramatic encounter, likely a near-miss collision with another galaxy millions of years ago. Imagine two dancers whirling past each other in the dark. Even if they don't touch, their gravitational pull can send one spinning off balance. That's precisely what might have happened here, a gravitational brushstroke that left Hoags Object's outer edges permanently distorted while leaving its inner structure bizarrely untouched. What's truly puzzling is how localized the damage appears. Most galactic collisions leave widespread havoc: torn spiral arms, scattered star clusters, or disrupted cores. But Hoags Object's inner ring remains pristine, as if sheltered from the chaos that warped its outer reaches. This implies the intruder galaxy must have passed at just the right angle and distance, close enough to tug the outer dust into disarray, but far enough to spare the delicate inner structures. It would be like a hurricane ripping apart a picket fence while leaving a house full of china cabinets unharmed. The dust itself holds more clues. Unlike the young, blue stars of the inner ring, this outer band consists mostly of frigid molecular clouds, the raw materials for future star formation that never quite got the memo to organize. Spectroscopy reveals bizarre chemical signatures within these clouds, including unusual ratios of carbon monoxide and complex organic molecules typically found in much denser galactic environments. Some astronomers speculate these molecules might be remnants of the intruder galaxy itself, cosmic fingerprints left behind as it grazed past Hoags Object long ago. Then there's the ring's motion, or rather, its conflicting motions. Different sections rotate at varying speeds, with some regions racing ahead while others lag stubbornly behind. This isn't how galactic rings typically behave. They usually move as cohesive units, bound by shared gravity. The irregular rotation suggests whatever disturbed this ring did so unevenly, perhaps delivering glancing gravitational blows that set different portions spinning at odd tempos. It's as if someone tried to stir a cup of coffee while randomly changing directions. You'd end up with swirling eddies going every which way, the most tantalizing feature. Glowing filaments of ionized gas stitch through the dust like luminous spiderwebs. These thin, glowing tendrils appear to connect the warped outer ring back to the galaxy's core, though how or why remains unclear. Some theories suggest they're cosmic lightning, arcs of energy somehow channeled across thousands of light years. Others propose they're tidal tails, streamers of material pulled outward during the ancient encounter, now glowing as they interact with intergalactic winds. What makes this outer dust ring so fascinating isn't just its current state, but what it reveals about cosmic timescales. The fact that the distortion persists after billions of years means the ring must be far more massive than it appears, perhaps 10 times denser than initial estimates, to resist gravity's smoothing effects over such vast stretches of time. It's like finding a fingerprint preserved in stone millions of years later. The impression only lasts if something substantial made it. This warped, twisting band of dust is more than just galactic debris. It's a forensic snapshot of a long-ago encounter, a reminder that even the most serene-looking cosmic objects carry scars from their violent past. As we study its kinks and swirls, we're not just mapping dust, we're reconstructing a collision that may have shaped one of the universe's most peculiar galaxies. And every new detail makes one thing clearer: in the cosmic dance of galaxies, even near misses leave lasting marks. Deep in the cosmic no man's land between Hoags Object's blazing core and its perfect blue ring drifts a stellar anomaly, a lonely cluster of ancient red giants glowing like embers in the void. These aren't just old stars, they're cosmic misfits huddled together in a pocket of space where no star should logically exist. Red giants typically form near galactic centers or within dense star-forming regions, yet here they float in near-total isolation, cut off from both the core's gravitational embrace and the ring's youthful energy. How did these aging giants end up stranded in the galactic equivalent of deep ocean? And why do they appear so startlingly out of place? The cluster's composition deepens the mystery. Spectroscopy reveals these stars aren't just old, they're nearly as ancient as the universe itself, with metal content so low they must have formed from primordial gas before heavier elements became common. That makes them galactic fossils, relics from a time when the first stars were still lighting up the cosmos. But this raises an impossible contradiction. If these stars are truly that old, why do they appear so youthful in their evolutionary phase? Red giants represent the final fiery throes of a star's life, yet their positions in the Hertzsprung-Russell diagram suggest they ignited their helium cores far later than peers from the same epoch. It's like finding a group of medieval knights casually scrolling through smartphones. Their very existence breaks expected timelines. One radical theory posits they might be interstellar immigrants, stars stolen from a dwarf galaxy that ventured too close to Hoags Object billions of years ago. When galaxies collide, their outer stars often get flung into wild orbits, and these red giants could be survivors of such an encounter, left to wander the void between structures. Yet their precise clustering argues against this. Captured stars would typically scatter, not maintain tight groupings over cosmic timescales. Alternatively, they might be the last members of a vanished star cluster, all other members long since evaporated away, a stellar version of a lone tree standing where a forest once grew. Even stranger is their motion. These giants drift against the galaxy's rotation like salmon swimming upstream, their trajectories tracing arcs that ignore Hoags Object's dominant gravitational currents. Normally, such rebellious orbits would require an unseen perturbing force, perhaps a concentration of dark matter or the ghostly pull of that long-lost dwarf galaxy. Some researchers speculate the cluster could be orbiting an invisible intermediate mass black hole, its gravity shepherding the stars into their unusual configuration. Others suggest the stars might be experiencing collective acceleration from the galaxy's own structure, like leaves caught in the wake of a speeding boat. The most tantalizing clue lies in their faint infrared halos. Each red giant is surrounded by an unusually thick envelope of dust, not the expected debris of aging stars, but material that appears artificially concentrated, as if some external force is corralling their stellar winds into shared shells. This implies the entire cluster might be plowing through an invisible molecular cloud, its interstellar medium piling up before the stars like snow before a plow. If true, it would mean the void between core and ring isn't empty at all, but filled with diffuse gas we simply can't detect. A hidden ocean these stellar giants are slowly sailing through. Whatever their origin, these red giants are more than celestial curiosities. They're living records of Hoags Object's turbulent past. Their positions, motions, and strange youthfulness all point to forces we've yet to fully understand, reminding us that even in the quietest corners of galaxies, the universe still has stories left to tell. And as we study their flickering light, we're not just observing aging stars, we're decoding a cosmic mystery written in the slow burn of helium and time. Amid the quiet emptiness between Hoags Object's golden core and its radiant ring, a single star defies all expectations, streaking across the void at nearly 1,000 kilometers per second. This isn't just a fast-moving star, it's a cosmic runaway, blazing a trail so furious it could cross the entire Milky Way in just a few million years. Most stars drift lazily through their galaxies, held in place by gravity's gentle tug. But this one, it's a bullet fired from some unseen cosmic gun, and its speed tells a story of unimaginable violence. Where did this stellar fugitive come from? The leading theory points to a close encounter with Hoags Object's supermassive black hole. Picture a slingshot maneuver gone wrong. If a binary star system ventured too near the black hole's event horizon, one star might have been captured while the other was flung away at breakneck speeds. Astronomers call these hypervelocity stars, and they're among the rarest objects in the universe. But here's the twist: this runaway isn't heading outward into intergalactic space. Instead, it's cutting a diagonal path across Hoags Object itself, as if whatever ejected it gave it an odd sideways kick. Then there's the puzzle of its composition. Spectroscopic analysis reveals this star is rich in heavy elements like oxygen and neon, materials typically forged in supernova explosions. That raises a provocative possibility. Maybe this star wasn't just flung away by gravity. It could have been standing too close to a massive companion when that companion exploded, the shockwave launching it like a cannonball. If true, that would make it not just a runaway but a survivor, a piece of shrapnel from a stellar catastrophe that occurred millions of years ago. The most baffling detail, though, is its trajectory. Unlike most hypervelocity stars that race in straight lines, this one follows a slight curve, hinting at unseen forces tugging at it. Some researchers speculate it might be passing through a dense patch of dark matter, its gravity subtly bending the star's path. Others wonder if it's being influenced by the warped outer dust ring, its magnetic fields, or turbulent gas creating drag. Every slight deviation in its course is a clue, one that might reveal hidden structures lurking in what we thought was empty space. What's certain is that this star doesn't belong where it is. Its speed, its composition, its odd path, all of it points to a dramatic past we can only piece together from the echoes. And as it hurtles through Hoags Object, it's not just leaving a trail of light, it's etching a question into the cosmos. What kind of force could send a star flying like this? The answer might rewrite what we know about galactic chaos and the invisible forces that shape it. On the outermost fringes of Hoags Object, hidden among the swirling dust and dim stellar remnants, something is broadcasting. Not in visible light, not in X-rays, but in radio waves pulsing across the cosmos with eerie precision. Detected by deep space observatories decades ago, this enigmatic signal defies easy explanation. Unlike the chaotic static of pulsars or the random bursts of magnetars, this emission follows a pattern, a sequence of pulses repeating every 176 hours like clockwork, each burst lasting exactly 12 minutes before falling silent again. What makes this transmission truly unsettling is its location. Most natural radio sources originate near energetic objects, black holes, neutron stars, or dense star-forming regions. Yet this signal emanates from an unremarkable patch of space on the galaxy's edge, where nothing should be capable of producing such powerful, structured emissions. The signal's narrow frequency bandwidth is another red flag. Natural cosmic phenomena typically broadcast across wide swaths of the spectrum, while this one is tightly focused, almost like a laser beam cutting through interstellar static. Astronomers have proposed theories, some mundane, others extraordinary. One camp argues it could be an undiscovered type of rotating neutron star, its polar beams sweeping past Earth at an angle that creates this unusual periodicity. Others speculate about planetary pulsars, hypothetical super-dense planets with magnetic fields strong enough to generate detectable radio waves as they spin. But neither explanation fully accounts for the signal's unnatural-seeming regularity or its curious spectral purity. Then there's the provocative possibility: could this be artificial? The idea isn't as far-fetched as it seems. In the 1960s, scientists devised the WOW signal criteria-specific radio signatures that might indicate intelligent origin. This transmission ticks several boxes: narrow bandwidth, repeating structure, and an absence of natural harmonics. Of course, extraordinary claims require extraordinary evidence, and most researchers caution against jumping to conclusions. But the similarities to hypothetical beacon signals, the kind an advanced civilization might use to announce its presence, are difficult to ignore. Curiously, the signal's intensity fluctuates over years in a way that doesn't match any known astrophysical process. Detailed analysis reveals it dims and brightens in cycles that correlate with Hoags Object's orbital motion, as if whatever's producing it is somehow synchronized with the galaxy's movement through intergalactic space. This bizarre synchronization has led some to propose the source might be tapping into larger-scale cosmic structures for power, like a sail catching the solar wind. The most unsettling detail, however, lies in the signal's content, or rather, its lack thereof. Despite decades of analysis, no discernible information has been decoded from the pulses. They don't vary in ways that suggest modulation, nor do they match mathematical sequences we might expect from an intentional broadcast. It's just the same unchanging pattern repeating across eons, as if carrying a message we're not equipped to understand, or perhaps not meant to. Whether natural or not, this persistent signal forces us to confront a humbling truth. In a galaxy as strange as Hoags Object, even the most familiar phenomena might hide depths we've yet to fathom. And as those radio waves continue their metronomic march across the cosmos, they serve as a reminder sometimes the universe's most profound mysteries don't announce themselves with fireworks, but with the patient, unblinking rhythm of a heartbeat in the dark. Stretching like a luminous scar across Hoags Object's perfect blue ring, a sinuous filament of superheated gas glows with an intensity that outshines even the youngest stars around it. This isn't just a wispy cloud, it's a cosmic lightning bolt frozen in time, radiating energy at frequencies that make it visible across intergalactic distances. Most gas filaments in galaxies are cold and dark, barely noticeable against the backdrop of stars, but this one burns so fiercely it defies conventional astrophysics, and its very existence hints at forces at work we've yet to fully comprehend. The filament's origins trace back to an ancient cataclysm. Spectroscopy reveals it's rich in elements like ionized oxygen and neon, materials typically forged in the hearts of massive stars and scattered by supernova explosions. This suggests the filament might be the ghostly aftermath of a stellar detonation so powerful it sent shockwaves rippling through the surrounding gas, compressing and heating it into this glowing ribbon. But there's a problem with that theory. The filament structure is too orderly. Supernova remnants usually expand chaotically, like smoke rings in a hurricane. This one, by contrast, maintains an eerie symmetry, as if guided by invisible hands. One compelling explanation involves the galaxy's magnetic fields. Hoags Objects perfectly aligned in a ring might generate magnetic forces strong enough to channel exploding stellar material into narrow, coherent streams. Picture water forced through a hose. The pressure creates a focused jet. Similarly, the filament could be the result of supernova ejecta funneled by magnetic fields into this precise, glowing pathway. Supporting this idea are faint radio emissions detected along the filament's length. a telltale sign of charged particles spiraling along magnetic field lines. Yet the real mystery lies in the filament's persistence. Gas this hot should dissipate quickly, cooling and blending into the surrounding medium within a few million years. Instead, the filament has endured for what appears to be tens of millions of years, glowing with undiminished brilliance. Some researchers propose it's being continuously reheated, perhaps by cosmic rays or turbulence from nearby star formation. Others speculate it might be interacting with dark matter, an invisible gravitational scaffold that's somehow transferring energy to the gas, keeping it perpetually ablaze. Then there's the enigma of its motion. Unlike the rest of Hoags Object's ring, which rotates smoothly, the filament writhes with internal turbulence. High-resolution observations show sections of it moving independently, some portions racing ahead while others lag behind, creating kinks and braids in its structure. This could imply the filament isn't a single entity, but a collision zone where multiple streams of gas are grinding against one another, their friction generating the intense heat we observe. Whatever its origins, this glowing filament is more than just a celestial curiosity, it's a cosmic laboratory. Its behavior challenges our understanding of how energy dissipates in space, how magnetic fields shape galaxies, and how interstellar gas responds to extreme conditions. And as we study its shimmering light, we're not just observing a strand of superheated gas, we're decoding a message from the universe about the hidden forces that stitch galaxies together. At the very edge of Hoags Object's glowing blue ring, a cosmic dance of destruction unfolds. A small, disheveled dwarf galaxy is being torn apart by gravity, its stars strewn across space like glitter spilled from a shattered snow globe. This isn't just a distant neighbor passing by, it's an intruder caught mid-collision, its fate already sealed as it spirals toward complete annihilation. The dwarf's chaotic approach has sent shockwaves through Hoags Object's pristine ring, warping sections of it into jagged arcs and igniting pockets of chaotic star formation where none should exist. The violence of this merger reveals itself in the debris. Long tendrils of stars, some ripped from the dwarf, others dislodged from Hoags Object itself, trace the dwarf's death spiral like breadcrumbs leading back to the moment of impact. These stellar streams crisscross the ring in chaotic patterns, their trajectories defying the galaxy's orderly rotation. In some areas, the dwarf's gravity has compressed gas clouds so violently that new stars erupt in frenzied bursts, their blue-white light clashing with the older, cooler stars around them. Elsewhere, the collision has carved gaps in the ring, as if a giant hand reached in and scooped out handfuls of stars. What makes this merger especially bizarre is its asymmetry. Most galaxy collisions trigger fireworks on all sides: supernova, shock waves, tidal tails extending in every direction. Here, the damage is curiously lopsided, concentrated on just one segment of the ring. This suggests the dwarf didn't strike head-on, but instead sideswiped Hoags Object at an odd angle, like a bullet grazing a spinning top. That glancing blow may explain why the ring's overall structure remains intact. The rest of the galaxy seems almost unaware of the carnage unfolding at its edge, as if the collision is happening in slow motion, its full effects yet to ripple inward. Then there's the dwarf galaxy itself, or what's left of it. Once a modest collection of stars and gas, its core now hangs like a broken pendulum, swinging wildly through Hoags Object's outer reaches. Observations reveal its central black hole, tiny compared to Hoags Object's behemoth, has been yanked from its perch and sent tumbling through the ring, trailing a wake of ionized gas bright enough to outshine entire star clusters. This runaway black hole could be seeding chaos in its path, stirring up turbulence that might trigger even more star formation or, conversely, suppress it entirely in certain regions. The most startling discovery: this merger might not be the first. Deep imaging uncovers ghostly tendrils of stars weaving through Hoags Object's outskirts, faint, ancient streams that could be the remnants of past galactic encounters. If true, it would mean Hoags Object has been cannibalizing smaller galaxies for billions of years, each collision adding to its perfect ring while erasing the evidence of its violent past. The current dwarf's demise, then, isn't an anomaly, it's part of a cycle, one that might explain how such an otherworldly structure persists in a universe where chaos usually reigns. As we watch the dwarf galaxy unravel, we're witnessing more than just destruction, we're seeing creation in action. Every twisted stream of stars, every pocket of newborn suns, is a brushstroke in an evolving masterpiece, one that challenges our assumptions about how galaxies grow, change, and occasionally defy the odds to remain breathtakingly beautiful. Nestled within the radiant blue ring of Hoags Object, a dark vortex churns silently, a perfect circle of absolute nothingness where stars refuse to form and light seems to vanish without a trace. This isn't just a gap in the stellar fabric, it's an active void, a cosmic whirlpool dragging surrounding gas and dust into its inky depths. While most black holes announce their presence with blazing accretion disks or violent jets, this one hides in plain sight, its gravitational influence betrayed only by the eerie way stars at the vortex's edge whip around an invisible center at impossible speeds. The vortex's scale defies logic, stretching nearly 1,000 light-years across. It dwarfs typical stellar mass black holes, yet remains curiously small for a supermassive one. Its gravitational pull suggests an object weighing in at around 20,000 solar masses, an awkward middle child in the black hole family, too big to form from a dying star yet too small to anchor a galaxy's core. These intermediate mass black holes are among the rarest objects in the universe, with only a handful of potential candidates ever identified. If confirmed, Hoags Object's vortex could solve one of astronomy's greatest mysteries. Where do supermassive black holes come from? But there's a problem. Black holes this size should glow fiercely as they consume matter, heating surrounding gas until it radiates X-rays. Yet this vortex remains stubbornly dark, emitting no detectable high-energy signals. Some theorists propose it might be a failed quasar, a black hole that exhausted its fuel supply eons ago, leaving behind a dormant gravity well. Others speculate it could be wrapped in an exotic cocoon of dark matter, its gravitational effects amplified by invisible particles crowding around it like cosmic insulation. The most unsettling possibility, this might not be a black hole at all. Alternative explanations range from a dense knot of dark matter, so concentrated it mimics a black hole's pull, to a theoretical gravistar, a hypothetical object with a black hole's exterior but a bizarre core of vacuum energy. Then there's the wildcard idea, a primordial wormhole, a relic from the universe's first moments when spacetime itself might have knotted into tunnels. While these concepts sound like science fiction, Hoags Object's vortex fits none of the standard profiles, forcing astronomers to consider options that would rewrite physics textbooks. Clues hide in the vortex's motion. Unlike the rest of the ring, which rotates uniformly, this dark maelstrom drifts slowly counterclockwise as if fighting the galaxy's flow. Gas clouds spiral into it at odd angles, some accelerating abruptly while others break against unseen resistance. These anomalies suggest something is interfering with the vortex's gravitational field. Perhaps a second, smaller companion object orbiting it, or external forces from the galaxy's warped dark matter halo. What's certain is that this vortex doesn't belong. Its very existence challenges our understanding of how black holes form and evolve, presenting a cosmic puzzle with pieces that refuse to fit. Whether a missing link black hole, a dark matter anomaly, or something even more extraordinary, it reminds us that the universe still holds shadows we've yet to illuminate, and that some of its most profound secrets might lie not in the glittering stars but in the darkness between them. Locked in a deadly cosmic waltz at the heart of Hoags Object's blue ring, two neutron stars spin around each other so close they could fit between Earth and the Moon. These aren't just any dead stars, they're ultra-dense corpses, each weighing more than our Sun yet compressed into a sphere no wider than a city. What makes this pair extraordinary isn't just their proximity. It's the way they distort space-time itself, sending ripples through the fabric of the universe that detectors on Earth have actually felt. Neutron star binaries are rare enough, but this duo defies all expectations. Most orbit at safe distances, taking days or weeks to complete a single loop. These two complete a full revolution every 47 minutes, so fast their surfaces streak through space at 15% the speed of light. At this pace, their crushing gravity strips material from each other's atmospheres, creating a swirling bridge of superheated plasma that glows with the energy of a million suns. The resulting friction should be slowing them down, dragging them toward an inevitable collision. Yet, decade after decade, their orbit remains mysteriously stable, as if some unseen force is feeding them energy to keep this dance alive. Then there are the gravitational waves. Every spiraling orbit sends tremors through space-time, subtle distortions predicted by Einstein over a century ago. While most neutron star pairs emit faint, steady waves, this binary produces sharp, erratic pulses. It's as if their dance floor isn't level. Some researchers suspect Hoags Object's warped dark matter halo might be to blame, its uneven gravity tugging on the stars in ways that twist their signals. Others propose one of the neutron stars could be a strange quark star, a hypothetical object even denser than ordinary neutron matter whose exotic physics alters the gravitational waves in ways we don't fully understand. The most tantalizing clue lies in their magnetic fields. Normally, paired neutron stars synchronize their magnetic poles over time. These two maintain wildly mismatched fields, with one star's magnetic axis tilted nearly 90 degrees from its partners. This misalignment creates a cosmic generator, accelerating particles to relativistic speeds that produce brilliant gamma-ray flashes every orbit. These flashes arrive at Earth with such precision you could set your watch by them. Yet their intensity varies unpredictably, as if something in the surrounding environment is intermittently dimming the signal. What truly captivates astronomers isn't just how these stars behave, but how long they've survived. Neutron star pairs this tight should collide within a few million years. Yet spectral analysis suggests this duo has been orbiting for nearly 1 billion, 10 times longer than the rules of physics say they should. Their resilience hints at untold stories. Perhaps they've stolen energy from passing gas clouds, or maybe they're not native to Hoags Object at all, but intergalactic travelers captured during some ancient encounter. As they continue their relentless dance, these twin neutron stars do more than warp space-time. They stretch our understanding of stellar evolution. Every flicker, every gravitational ripple carries secrets about the extreme physics governing the universe's most violent neighborhoods. And when they finally do collide, whether tomorrow or 1 million years from now, the resulting explosion won't just light up Hoags Object. It'll broadcast a masterclass in cosmic physics across the entire observable universe. Buried within the golden glow of Hoags Object's core, a single star stands out like a relic from another age, its light carrying the chemical fingerprints of a cosmic disaster long forgotten. This ancient sun, nearly as old as the universe itself, shouldn't exist as we see it. Stars this old are supposed to be metal poor, composed mostly of hydrogen and helium, the pristine elements forged in the Big Bang. Yet this one defies the rules, its spectrum revealing shocking amounts of heavy elements like gold, platinum, and uranium materials that only form in the most violent stellar explosions. How did these metals end up inside a star that predates them? The answer might rewrite what we know about the early universe's capacity for chaos. The anomaly becomes even clearer when you examine the star's position. Nestled deep in the galactic core, it orbits perilously close to the supermassive black hole, a region where gravity's grip should have torn apart any loose stellar material billions of years ago. That it survived suggests an extraordinary past. One compelling theory posits this star wasn't born here at all, but was kidnapped, Picture a dwarf galaxy, rich in heavy elements from early supernova, straying too close to Hoags Object in the distant past. As the smaller galaxy was shredded by tidal forces, this star, already ancient then, was flung into the core, its rogue trajectory somehow stabilizing into this unlikely orbit. Then there's the mystery of its composition. The star's heavy elements aren't just present, they're layered in ratios that make no sense for standard stellar evolution. Normally, metals distribute evenly when a star forms from an enriched gas cloud. Here, certain rare elements like europium and osmium appear concentrated in patches, as if injected directly into the star's outer layers long after its birth. Some astronomers speculate this could be evidence of a neutron-star merger, a spectacular collision that occurred nearby when this star was already middle-aged, showering it with freshly forged R-process elements. Imagine standing outside a goldsmith's workshop during an explosion, your clothes flecked with molten precious metals. That's essentially what might have happened to this stellar oddity. But the most tantalizing clue lies in the star's spin. Unlike most elderly stars that rotate sedately, this one whirls at breakneck speed, completing a full rotation every few days. Such rapid spinning typically indicates a recent gravitational encounter, perhaps a close brush with the central black hole that literally whipped it into a frenzy. Alternatively, it might have cannibalized a smaller companion star, absorbing both its mass and angular momentum in the process. Either scenario would explain the star's youthful vigor, but raises another question. Why haven't its heavy elements sunk toward the core over time? In stars this old, diffusion should have dragged denser materials inward long ago, yet they remain suspended near the surface like glitter in a snow globe. This ancient star is more than a cosmic curiosity, it's a time capsule. Its peculiar chemistry suggests the early universe was far more dynamic than we thought, capable of producing heavy elements and distributing them in ways that challenge conventional timelines. And as we decode its light, we aren't just studying a single star, we're piecing together a lost chapter of galactic history, one where collisions, explosions, and gravitational mayhem shaped the cosmos long before Hoags Object's famous ring ever took form. Amid the sparkling expanse of Hoags Object's ring, astronomers have stumbled upon something that shouldn't be possible, a star cluster that plays cosmic hide and seek. One moment it's there, a tight-knit family of hundreds of stars glowing brightly in telescopic images. The next, it's gone without a trace, as if some unseen hand flicked a switch and erased it from the sky. Then, months or even years later, it reappears right where it was, untouched and seemingly unaware it ever vanished. This isn't a glitch in observations or a trick of the light. Multiple telescopes from Hubble to the Very Large Array have confirmed the phenomenon. The cluster isn't just dimming, it's disappearing, only to materialize again with no explanation. What could cause an entire star cluster to blink in and out of existence? One possibility involves an ultra-dense cloud of cold gas drifting through the galaxy. Unlike typical nebulae, which glow when lit by nearby stars, this hypothetical cloud would be nearly pitch black, a cosmic stealth blanket absorbing all light from the cluster behind it. As it moves across our line of sight, the cluster would vanish, then reappear once the cloud passes. The problem: gas clouds this dense should collapse under their own gravity, triggering star formation and lighting up. Yet no such glow has been detected, leaving astronomers to wonder if this is something even stranger. Perhaps a rogue molecular cloud laced with dark matter, its gravity holding it together without the usual emissions. Then there's the gravitational lensing theory. If an extremely compact, massive object like a wandering black hole or a knot of dark matter floated between Earth and the cluster, its gravity could bend light around it, rendering the cluster temporarily invisible. But lensing usually distorts or magnifies background objects rather than erasing them completely. For this effect to occur, the alignment would need to be impossibly precise, like threading a needle across thousands of light years. Even more baffling, the cluster's reappearances show no signs of distortion or redshift, as lensing would typically produce, the most unsettling explanation. The cluster might not be vanishing at all, we might be seeing through it. Some theorists suggest it could be a ghostly, dark star cluster, composed mostly of stellar remnants like black holes and neutron stars too faint to detect. Normally, such clusters would still have a few visible stars mixed in, but if, by some freak cosmic coincidence, this one formed entirely from dead stars, it would explain why it only becomes visible when something luminous like a passing gas cloud illuminates it briefly before fading again. Whatever the truth, this disappearing act challenges our assumptions about how star clusters behave. Most evolve over billions of years, their fates written in the slow burn of stellar lifetimes. This one seems to operate on a whim, flickering in and out of the cosmic record like a message written in invisible ink, and as long as it keeps vanishing, it serves as a humbling reminder. Even in an age of advanced telescopes, the universe still holds mysteries that refuse to stay put long enough to be solved. Stretched like celestial bookends across Hoags Object's blue ring, two dust clouds mirror each other with uncanny precision, each a near-perfect replica of the other in shape, size, and even internal structure. At first glance, they could be twins separated by 20,000 light-years, their swirling tendrils and dense cores aligned as if arranged by some cosmic choreographer. The odds of such symmetry arising naturally are astronomically low. Dust clouds in galaxies typically form in chaos, shaped by turbulent stellar winds and random collisions. Yet here, against all probability, these two structures reflect one another down to the subtlest details, as if the universe itself pressed a cosmic stamp onto opposite sides of the ring. The mirroring goes beyond mere appearance. Spectroscopic analysis reveals their chemical compositions are virtually identical, unusual concentrations of silicate grains mixed with frozen carbon monoxide, a recipe more commonly found in the hearts of dense molecular clouds than in isolated patches like these. Even their temperatures match within a fraction of a degree, with both registering strangely warm for their location, as if sharing some hidden energy source. What makes this even stranger is their motion. While the rest of the ring rotates uniformly, these two clouds move in perfect sync, their velocities locked in step despite the vast distance between them. It's as though an invisible thread connects them, orchestrating their dance across the eons. One theory points to a gravitational echo. If a massive object, perhaps a rogue black hole or a cluster of dark matter, passed through the ring long ago, it might have triggered twin shockwaves that compressed gas into identical formations on opposite sides. Imagine dropping two pebbles into a still pond at the same moment. The ripples would mirror each other, but this explanation falters when you consider the scale. For shockwaves to create such precise symmetry across such distances, the triggering event would need impossible precision, like a bullet passing cleanly through a galaxy without disturbing anything else. Another possibility involves magnetic fields. Hoags Object's ring generates powerful magnetic forces that could, in theory, sculpt gas into aligned structures. Yet magnetic fields usually create arcs or filaments, not isolated, matching clouds. Even more puzzling, these clouds show no signs of the telltale polarization that would confirm magnetic shaping. Their particles scatter light randomly, betraying no preferred orientation. Then there's the wildcard idea. These clouds might be remnants of a single, even larger structure that once spanned the ring. If a titanic dust torus, a donut-shaped cloud, encircled Hoags Object long ago, gravitational instabilities could have fractured it, leaving behind these two surviving fragments. Over time, they'd have drifted into their current positions, their shared origin preserving their eerie similarity. Supporting this, faint infrared echoes suggest ghostly tendrils of dust might still bridge the gap between them, too diffused to see directly but detectable in their subtle warmth. The most tantalizing clue lies in their star formation, or lack thereof. Dust clouds this dense should be stellar nurseries brimming with newborn stars. Yet both remain eerily quiet, their cores unlit by the nuclear fires of protostars. It's as though something is suppressing star birth within them, freezing them in a state of suspended animation. Some researchers speculate their matched symmetry might be the cause. Perhaps their mutual gravitational influence is stabilizing them against collapse, like two hands cupping water without letting it spill. Whether echoes of a cataclysm, magnetic artworks, or fragments of a lost ring, these mirror image clouds defy every expectation. They're more than curiosities, they're cosmic puzzles, challenging us to rethink how order emerges from chaos and whether the universe sometimes plays favorites with its designs. And as we study their matched silhouettes, we're left wondering, are we seeing a fleeting coincidence or evidence of a hidden law of balance we've yet to name? Tucked between the blue stars of Hoags Object's outer ring, a faint, twisting nebula glows with the ghostly energy of a catastrophe older than human civilization. This isn't just another gas cloud, it's the scorched remains of a gamma-ray burst, the universe's most violent explosion, detonated so brightly it would have outshone entire galaxies for a terrifying moment in cosmic history. The nebula's delicate filaments, now cooling across millennia, are all that's left of a star that died in a way astronomers once thought impossible, unleashing a focused beam of radiation so intense it sterilized everything in its path for thousands of light years. What makes this remnant so chilling isn't just its past fury, but the way it warps our understanding of galactic safety. Gamma-ray bursts typically occur in distant, metal-poor regions of the universe, not in relatively modern galaxies like Hoags Object. This one's presence suggests the galaxy might have had a catastrophic adolescence, a period when conditions were far more volatile than its serene ring structure implies. The nebula's chemical fingerprints tell the story. Traces of nickel-56 and titanium-44, isotopes forged only in the heart of a hypernova, a stellar collapse so extreme it borders on theoretical. Yet the real mystery lies in the remnant's shape. Unlike most gamma-ray burst afterglows which expand in rough spheres, this one forms a slender, corkscrewing jet, a scar frozen in time, preserving the exact angle of the original deadly beam. By tracing its trajectory backward, astronomers made a stomach-churning discovery. That beam was pointed directly at Hoags Object's core when it fired. For a brief instant billions of years ago, the galaxy's central black hole and its surrounding stars were bathed in radiation trillions of times more intense than our sun's output. The energy would have stripped atmospheres, shattered DNA, and rewritten the rules for life across hundreds of star systems, which raises an unsettling question: could life have existed here before the blast? The timing is provocative. Hoags Object's golden core contains stars nearly as old as the universe itself, plenty of time for planets to form and perhaps even nurture primordial life. If any civilizations arose in those early epochs, they would have had no warning before the gamma-ray burst's light scoured their worlds clean. Some researchers speculate the burst might explain the eerie gap between the galaxy's core and ring. Perhaps it cleared a vast sterilization zone, a cosmic dead space where not even microbial life could cling on. But the remnant holds clues to more than just destruction. Embedded within its tangled filaments are microscopic diamonds, carbon crystals forged in the explosion's shockwaves, each one a time capsule from the moment of detonation. Even more astonishing, these diamonds contain trace impurities of meteoritic minerals, suggesting the blast vaporized not just a star, but entire planetary systems orbiting it. It's a sobering reminder that when stars die catastrophically, they rarely die alone. Today, the nebula glows faintly in X-rays, its radiation now harmless after billions of years of diffusion. Yet its very existence forces us to confront a humbling truth. Even the most beautiful galaxies can harbor violent pasts, and the universe's capacity for creation is matched only by its talent for annihilation. As we study this scar in Hoags Object's ring, We're not just observing a relic, we're reading a cautionary tale written in the ashes of a star that burned too bright, too fast, and left behind a warning etched across the cosmos. Drifting silently through the inky blackness between Hoags Object's core and its glowing ring, a rogue world wanders, a planet without a sun, untethered from any star, moving through space like a cosmic castaway. This isn't just another cold, dead rock. It's a planetesimal, a relic from the early days of the galaxy, when systems were chaotic and gravitational shoving matches routinely flung worlds into the void. Most rogue planets are frozen wastelands, their surfaces plummeting to near absolute zero without a star to warm them. But this one defies expectations, emitting a faint, eerie infrared glow that suggests residual heat, perhaps from a still active core or lingering radioactive decay, keeping it strangely warm against the backdrop of interstellar space. The planetesimal's origins tell a story of cosmic violence. Its trajectory suggests it didn't form in isolation, but was violently ejected from a star system long ago, hurled into the abyss by gravitational forces we can only reconstruct through simulations. Picture a young planetary system, still unstable, with gas giants jostling for position. In the chaos, a close encounter between two massive worlds could have acted like a gravitational slingshot, accelerating this one to escape velocity and banishing it to the darkness. Supporting this theory are deep scans revealing a heavily cratered surface, some impacts so colossal they must have occurred shortly after ejection, as if the planetesimal plowed through a debris field in its desperate flight. What makes this wanderer especially fascinating is its atmosphere, or rather, the ghost of one. Spectroscopic analysis detects traces of noble gases like xenon and krypton, isotopes typically trapped beneath planetary crusts unless unleashed by catastrophic events. This implies the planetesimal once had a substantial atmosphere, stripped away either during its violent ejection or over eons of exposure to interstellar radiation. Yet somehow, pockets of it remain, clinging to the surface in frozen deposits like cosmic frost, hinting at a past where this world might have been warmer, maybe even habitable. Then there's the mystery of its composition. Unlike most rogue planets, which tend to be icy or rocky, this one's density readings suggest a hybrid structure, a metallic core wrapped in layers of silicate mantles and exotic ices, a mix that shouldn't exist in a single object. Some researchers speculate it could be a chimera, the shattered remains of two colliding protoplanets fused together before being flung into exile. Others propose it might be a refugee from another galaxy altogether, captured by Hoags Object during an ancient encounter. The most tantalizing clue lies in its path. This planetesimal isn't drifting aimlessly, it's tracing a slow, deliberate arc that will eventually bring it shockingly close to the galaxy's central black hole. In a few million years, its trajectory could slingshot it entirely out of Hoags Object, sending it careening into intergalactic space. Or, if it veers too close, the black hole's tidal forces might shred it apart, creating a fleeting but spectacular light show. For now, this lonely world continues its silent journey, a testament to the universe's untamed nature. It reminds us that for every planet neatly orbiting a star, there may be countless others lost to the darkness, each one a story of chaos, survival, and the relentless pull of gravity. And as we study its faint infrared whisper, we're not just observing a drifting relic, we're piecing together the hidden history of orphaned worlds and the unseen forces that shape their solitary path. Amid the perfect symmetry of Hoags Object's blue ring, a single jagged streak cuts through the celestial harmony, a fragment of a spiral arm frozen mid-unraveling, its stars trailing like brushstrokes across the galaxy's canvas. This isn't just a random scattering of stars, it's a fossilized relic, a glimpse into a time when Hoags Object might have looked radically different. Most ring galaxies form through violent collisions that erase their past structures, leaving no trace of what came before. But this fragmented arm tells a different story, one of gradual transformation, a cosmic metamorphosis caught halfway between spiral and ring. The fragment structure reveals clues to its origins. Unlike the orderly rotation of the surrounding ring, these stars move in chaotic arcs, their velocities mismatched like a symphony missing half its notes. Some race ahead, tugged by unseen forces, while others lag as if reluctant to join the galaxy's new dance. Their chemical composition deepens the mystery. These stars are older and richer in metals than their blue ring neighbors, suggesting they belong to an earlier era, perhaps the original spiral galaxy that once dominated here. It's as if we're seeing a snapshot of the moment that galaxy began to unravel, its arms fraying into the perfect ring we observe today. How does a spiral galaxy become a ring without total destruction? The fragment hints at an alternative to the classic collision theory. Instead of a head-on smash-up, Hoags Object might have experienced a gentler encounter, a near miss with another galaxy whose gravitational tide stretched its spiral arms outward like taffy. Over time, those stretched arms could have broken apart, their stars either scattering or settling into the new ring structure, while this single fragment remained stubbornly intact, a holdout refusing to conform. Supporting this idea are faint tendrils of hydrogen gas connecting the fragment to the main ring, like threads tethering a drifting balloon, but there's a puzzle. Spiral arm fragments should dissolve over time, their stars absorbed into the larger structure. Yet this one persists, its stars bound together more tightly than gravity alone can explain. Some researchers propose the presence of dark matter. An invisible knot of it might be clinging to these stars, anchoring them against the galaxy's pull. Others speculate magnetic fields could play a role, with Hoags Object's unique magnetism preserving the fragment like a bug trapped in amber. The most tantalizing detail lies in the fragment's youngest stars. Nestled among the ancient suns are pockets of blue supergiants, massive, short-lived stars that shouldn't exist in such an old structure. Their presence suggests star formation occurred here recently, as if the fragment isn't just a relic but an active participant in the galaxy's evolution. Could this be a sign of ongoing transformation, proof that Hoags Object's ring is still assembling itself? Or does it point to something stranger, a galactic wound that never fully healed, where new stars are born from the ashes of the old? This lone spiral fragment is more than a curiosity, it's a portal. By studying its twisted starlight, we're not just seeing a galaxy as it is, we're witnessing what it was and maybe even what it's becoming. And in that tension between past and present, Hoags Object whispers a reminder. Even the most perfect cosmic structures carry scars from their journey through time. Glowing brighter than 1,000 suns, Object 19 fools even the most advanced telescopes at first glance, a dazzling beacon of light that appears to be a quasar, one of the universe's most energetic phenomena. But when astronomers trained their instruments closer, they uncovered a cosmic riddle. This object shines with all the brilliance of a quasar, yet none of the telltale signs. Instead of the blistering jets of plasma and swirling accretion disks typical of these cosmic powerhouses, Object 19 pulses with a strange, almost melodic rhythm, its energy signature humming across wavelengths in a way that defies every known quasar profile. The deception begins with its light. True quasars are powered by supermassive black holes violently consuming matter, their radiation spanning from radio waves to gamma rays. Object 19, though, emits a curiously narrow band of ultraviolet and infrared light, as if someone took a quasar spectrum and erased everything but these specific colors. Even more perplexing, its brightness fluctuates in smooth, predictable waves unlike the chaotic flickering of actual quasars, which flare and dim like candles in a storm. It's as though the universe handed us a counterfeit bill, meticulously crafted to pass casual inspection but crumbling under scrutiny. So what's really fueling this imposter? One theory points to an unlikely culprit, a densely packed cluster of young, superhot stars, each one burning at temperatures that mimic quasar-like intensities. Normally, such stars would be scattered across a galaxy, their individual contributions blending into the background. But here, they might be concentrated in a tight orbital dance, their combined light masquerading as a single, impossibly bright point. Supporting this idea are faint emission lines in Object 19 spectrum chemical fingerprints matching those found in stellar nurseries, not the hellish environments around black holes. Then there's the wildcard hypothesis, a failed quasar. Some researchers speculate this could be a supermassive black hole that ran out of fuel long ago, its accretion disk evaporated to a ghostly wisp. What we're seeing might be the last gasp of that dying engine, a final, brilliant outburst powered by residual heat or magnetic friction, like a car engine revving wildly after the fuel line's been cut. If true, Object 19 could represent a fleeting stage in galactic evolution, one so rare we've never caught it in the act until now. The most tantalizing clue lies in its surroundings. Unlike true quasars, which often sit in isolated, ancient galaxies, Object 19 is embedded in Hoags Object's vibrant blue ring, surrounded by newborn stars and glowing gas. This unexpected location suggests its energy might be interacting with the ring in bizarre ways. Infrared scans reveal delicate filaments stretching from the object into nearby dust clouds, threads of ionized gas that hum with electrical currents, as if Object 19 is somehow charging the fabric of the galaxy around it. Whether a stellar illusion, a dying titan, or something else entirely, this quasar impersonator challenges our cosmic vocabulary. It forces us to ask, when we label phenomena across the universe, how many are we getting wrong? And in the gaps between what we know and what we assume, what other marvels might be hiding in plain sight? Deep within Hoags Object's outer debris field, tumbling silently through the darkness, an asteroid glitters like a cosmic geode, its surface encrusted with crystalline structures so vast they reflect starlight like fractured mirrors. This isn't just space rock, it's a time capsule forged in extreme conditions, its jagged facets recording cataclysmic events that shaped the galaxy long before its iconic ring took form. Most asteroids are rubble piles or metallic lumps, but this one gleams with kilometer-wide plains of crystalline minerals, some formations spiraling into cathedral-like spires that shouldn't survive the vacuum of space intact. The crystals themselves tell a story of violence. Spectral analysis reveals they're primarily composed of forsterite, a magnesium-rich silicate that only forms under blistering heat and pressure, conditions typically found near stars or in the aftermath of supernova. Yet here they coat an asteroid drifting far from any stellar furnace, their purity suggesting they condense directly from vaporized rock like snowflakes crystallizing from steam. The sheer scale of these formations points to an apocalyptic event, perhaps a white dwarf star's thermonuclear detonation nearby, bathing this region in temperatures exceeding 1 million degrees for centuries. Or maybe the asteroid was part of a shattered planetesimal. Its crust flash melted during a collision so violent it turned solid rock into an incandescent fog that later cooled into these glassy plains. Even stranger is the crystal's arrangement. Instead of chaotic clusters, they grow in geometric lattices, hexagonal columns, cubic fractals, even delicate dendritic patterns resembling frozen lightning. Such precision usually requires stable environments with gradual cooling, not the chaos of interstellar space. One theory suggests the asteroid might have spent millennia orbiting a neutron star, its surface bathed in rhythmic pulses of radiation that acted like a cosmic metronome, guiding crystal growth with unnatural order. Supporting this, faint traces of iridium and osmium pepper, the formation's metals often forged in neutron-rich environments, but the real enigma lies beneath the glittering crust. Radar scans reveal vast hollows within the asteroid caverns lined with even larger crystals, some stretching hundreds of meters. These chambers are too symmetrical to be impact cavities, their walls too smooth for natural erosion. Some researchers propose they might be bubbles from outgassing, where volatile compounds boiled away during heating events, leaving behind voids that later crystallized. Others speculate they could be the scars of exotic matter interactions, perhaps dark matter particles colliding within the rock, depositing energy that vaporized tunnels in cryptic patterns. The most tantalizing clue: the crystals are singing. Fine-tuned radio antennas have detected faint vibrations emanating from the asteroid, harmonic frequencies caused by thermal expansion as sunlight strikes different facets. These aren't random noises, they form repeating sequences that change predictably with the asteroid's rotation, almost like a cosmic wind chime ringing across the eons. By decoding these vibrations, scientists hope to reconstruct the asteroid's thermal history, but some patterns defy explanation, hinting at internal structures or resonances that challenge our understanding of crystalline physics. Whether a survivor of stellar fury, a relic of exotic orbits, or something even stranger, this crystal-encrusted wanderer is more than a celestial curiosity. It's a testament to the universe's capacity for artistry in the unlikeliest places, where chaos and precision collide to create beauty that outlasts stars. And as it tumbles through Hoags Object's shadows, it reminds us that even the smallest fragments of the cosmos can carry the echoes of events too vast to comprehend. Hoags Object's central black hole isn't as lonely as it seems. Lurking in its gravitational shadow, a second, smaller black hole traces a chaotic orbit around it, a cosmic dance so violent it sends tremors through the entire galaxy. Most supermassive black holes rule their domain solo, but this binary pair spins a far stranger tale. They're separated by a mere fraction of a light year, close enough that their gravitational pull shreds nearby stars into glowing streamers of plasma, their death screams lighting up the galaxy's core like a strobe in the abyss. What makes this duo so extraordinary isn't just their proximity, it's the way they warp Hoags Object's very fabric. Binary black holes are rare in mature galaxies. Over billions of years, gravitational waves should have sapped their orbital energy, forcing them to merge. Yet these two refuse to collide, locked in a stalemate that defies physics. Some researchers speculate an unseen force, perhaps a disk of gas or a dark matter halo, constantly injects energy into their orbit, like a pendulum perpetually nudged to keep it swinging. Others propose the smaller black hole might be a wanderer, captured by Hoags Object long after the galaxy formed, its trajectory still stabilizing from the encounter. Their gravitational tango has brutal consequences. Every close pass sends shockwaves rippling through the surrounding gas, triggering frenzied bursts of star formation in unexpected places. Normally, star births are confined to dense clouds in the ring, but near this pair, young stars flicker to life in the barren void between core and ring, their blue light defying the galaxy's usual symmetry. Even stranger, the black hole's erratic orbits appear to be sculpting the gap itself. Simulations suggest their combined gravity might act like a cosmic plow, clearing stars and gas from their path while herding material into the ring's sharp inner edge. The most alarming clue lies in their radio emissions. Most black hole binaries produce steady jets, but this system spews energy in erratic flares, some bright enough to outshine the entire galaxy for days. These outbursts don't match any known model. They're too frequent, too asymmetrical, as if the black holes are playing a game of gravitational tug-of-war with the surrounding matter. During one observed flare, the smaller black hole seemed to steal a clump of gas from its larger companion mid-orbit, triggering a pulse of X-rays that bounced between them like a cosmic pinball before erupting outward. The implications for Hoags Object's future are profound. If these black holes ever do merge, the resulting gravitational waves would ripple through the universe, detectable across billions of light years. But their current stalemate suggests a different fate: perpetual chaos. Their endless dance could keep the galaxy in flux, preventing the calm needed for the ring to settle into true equilibrium. Some astronomers even speculate this turbulence might explain why the ring stays so pristine, its stars constantly stirred but never scattered, like leaves caught in a whirlpool that never quite pulls them under. Whether destined to collide or orbit eternally, these twin monsters are rewriting the rules. They prove that even in a galaxy as serene as Hoags Object, the heart of darkness never beats alone, and that sometimes the universe's most beautiful structures are forged not by stillness, but by the tension between forces too powerful to ignore. Amid the sea of stars in Hoags Object's blue ring, one stellar outlier defies the laws of physics with a magnetic grip so powerful it could warp atoms into needles. Object 22 crackles with a magnetic field measuring over 10 billion Gauss, strong enough to strip the electrons off a hydrogen atom from 1,000 kilometers away. To put that in perspective, Earth's magnetic field measures about half a Gauss, and even the most extreme magnetars, the universe's known magnetic heavyweights, typically top out at around 100 billion Gauss. But this star isn't a magnetar. It's an otherwise ordinary-looking blue giant, the kind that shouldn't possess magnetism beyond a few thousand Gauss at most. Its existence is like finding a household refrigerator capable of freezing the Pacific Ocean. The mystery deepens when you examine how this star behaves. Most highly magnetic stars are neutron stars, collapsed stellar cores where extreme density amplifies magnetic fields to mind-bending levels. Object 22, however, still fuses hydrogen in its core, its outer layers churning with the turbulence of a living star. Yet somehow, its magnetic field eclipses anything its structure should allow. The field isn't just strong, it's structured in impossible ways, forming intricate geometric patterns across the star's surface like the iron filings of a cosmic fingerprint. Solar flares erupt along these magnetic seams, but instead of the chaotic loops seen on our Sun, they twist into perfect helices, as if the star's entire atmosphere is threaded by invisible cosmic wires. Researchers have scrambled to explain this anomaly. One radical theory suggests the star might be a magnetic fossil, the remnant of a long-dead companion, perhaps a neutron star that spiraled into its core during a catastrophic merger, leaving behind a magnetic ghost entangled in the surviving star's guts. If true, the star's outer layers could be a mask hiding a dense, magnetized corpse beneath. Supporting this, X-ray observations detect strange pulsations in Object 22 core rhythmic vibrations that match the theoretical wobble of a neutron star's influence trying to break free. Another hypothesis points to dark matter. Certain theoretical particles, like actions or magnetic monopoles, could theoretically cluster inside stars, amplifying their magnetic fields through interactions we don't yet understand. If Object 22 formed in a region dense with these particles, it might have absorbed them like a sponge, turning itself into a celestial electromagnet. Faint gamma-ray echoes around the star hint at particle decays consistent with some dark matter models, though the evidence remains tantalizingly indirect. But the most unsettling possibility, this star might not be breaking the rules. We might just be missing a page from nature's playbook. Some astronomers argue we're witnessing a never-before-seen phase of stellar evolution, where turbulent plasma currents in massive stars can spontaneously generate hyper-strong magnetic fields under rare conditions. Simulations show that under extreme rotation and density, a star's interior could act like a dynamo on steroids, winding magnetic lines into knots of staggering intensity. If so, Object 22 isn't an anomaly, it's a preview, showing us a hidden pathway stars can take, one that could rewrite how we classify magnetism across the cosmos. The implications ripple far beyond Hoags Object. If such magnetism can arise in ordinary stars, entire models of stellar physics, how stars form, how they die, even how they influence planetary systems, might need revision. Planets orbiting a star like this would face apocalyptic conditions, auroras brighter than their suns, atmospheres shredded by magnetic storms, and radiation so intense it could bake their surfaces into glass. It's a reminder that the universe doesn't just tolerate extremes, it thrives on them, crafting phenomena that force us to rethink the boundaries of what's possible. And as Object 22 continues to pulse its impossible magnetism into the void, it challenges us to ask, what else have we underestimated? Drifting through Hoags Object like a cosmic specter, an enormous hydrogen cloud stretching wider than the gap between the galaxy's core and ring, wreaks silent havoc on everything in its path. This isn't just diffuse gas, it's a rogue structure so massive it outweighs entire star clusters, yet so faint it was only discovered by the way it bends starlight passing through it, like heat ripples distorting a desert horizon. The cloud doesn't glow, doesn't collapse into stars, it simply exists, a shadowy leviathan weaving between celestial bodies and leaving chaos in its wake. Watch closely, and you'll see stars near the cloud's edges twitch erratically, their light flickering as if viewed through warped glass. These aren't random fluctuations. Each distortion traces the cloud's invisible contours, betraying its movement as it plows through the galaxy at nearly 200 kilometers per second. The sheer kinetic force of this motion creates shock waves in the surrounding interstellar medium, compressing gas into temporary filaments that glow briefly before dissolving. Yet the cloud itself remains eerily pristine, its hydrogen so undisturbed it's as though the galaxy's gravity refuses to acknowledge it exists. How does something this massive stay so intact? Most hydrogen clouds are shredded by galactic tides or stellar radiation, their atoms scattered across light years. This one defies the odds, its structure held together by some unseen scaffold. One theory suggests an interior magnetic field, woven through the cloud like a cosmic net, could be reinforcing it against disruption. Radio telescopes have detected faint polarization patterns in the background static, hints that magnetic forces might indeed be at play. Another possibility involves dark matter. If the cloud harbors a concentrated knot of it, the extra gravity could be counteracting tidal forces from Hoags Object itself, turning the cloud into a celestial bulldozer plowing through the galaxy's delicate structures. The real mystery, though, lies in the cloud's origins. Its trajectory suggests it didn't form within Hoags Object but arrived from intergalactic space, a wanderer from the void between galaxies, carrying the unaltered chemistry of the cosmic wilderness. Spectroscopy reveals its hydrogen is nearly pure, lacking the heavier elements typically found in galactic clouds, which are polluted by generations of supernova. This primordial composition makes it a living fossil, a relic from a time before stars seeded the universe with metals. If we could sample its atoms, they might carry clues about the conditions that existed before galaxies like Hoags Object even took shape. But the cloud's most dramatic impact is yet to come. Projections show it's on a collision course with a dense star-forming region in the blue ring. When it hits in roughly 10,000 years, the resulting shockwave could trigger a starburst so intense it would outshine the rest of the galaxy combined. Some simulations even suggest the collision might birth supermassive stars, monsters 100 times heavier than our Sun that would live fast, die young, and seed the area with enough heavy elements to forge entire planetary systems. For now, the cloud continues its silent march, a reminder that the universe's quietest forces often shape its grandest designs. And as it warps starlight and resists destruction, it poses a tantalizing question. How many other unseen giants might be moving through the cosmos, invisible architects rewriting galaxies in ways we're only beginning to perceive? Hidden in the outer reaches of Hoags Object's ring, a world shimmers with cold, unearthly fire, a planet so dense yet dazzling that astronomers first mistook it for a wandering diamond floating through space. This isn't just another exoplanet, it's a cosmic jewel, an entire world forged from crystallized carbon under pressures so extreme they turned ordinary matter into something extraordinary. Most diamond planets exist as theoretical curiosities, but this one, Object 24, pulses with spectral signatures matching compressed carbon lattices. its surface reflecting starlight with a prismatic glitter visible across interstellar distances. How does an entire planet transform into diamond? The story begins with stellar catastrophe. Billions of years ago, this world likely orbited a massive, fast-living star that died young in a supernova explosion. As the star collapsed, its outer layers blasted away, leaving behind a dense core, a white dwarf made mostly of oxygen and carbon. Over time, gravitational forces stripped away the white dwarf's outer layers, leaving its crystallized carbon core exposed. Imagine a cosmic blacksmith taking a stellar ember and hammering it into a perfect gem. That's essentially what happened here, with forces so intense they compressed carbon into a planet-sized diamond. But the real wonder lies beneath the glittering surface. Gravity measurements suggest the planet's crust isn't solid diamond. It's fractured into colossal tectonic plates of crystalline carbon, some spanning entire continents. These plates grind together at their edges, creating mountain ranges of pure graphite where the friction of shifting diamond generates enough heat to soften carbon into rare conductive forms. Lightning storms crackle through valleys of conductive Buckminster fullerene, their discharges etching intricate fractal patterns across the landscape. The planet's interior defies imagination. While Earth's core churns with molten iron, this world's heart may harbor exotic phases of carbon never seen naturally, perhaps even superconducting metallic hydrogen or superconducting carbon phases predicted in lab simulations but impossible to replicate on Earth. Some models suggest the intense pressure could have created a carbon ocean deep below the surface, a seething layer of supercritical fluid carbon where diamonds form like icebergs, rising slowly through the slurry to join the crust above. What's most astonishing is how this planet survived. Diamond worlds should be fragile, too brittle to withstand asteroid impacts or gravitational stresses over billions of years. Yet Object 24 bears the scars of countless collisions, its surface pockmarked with craters whose edges gleam like shattered glass. Somehow, the diamond lattice repairs itself over geologic time, with carbon atoms realigning into new crystalline structures after impact. It's as if the planet has a kind of cosmic self-healing property, maintaining its structural integrity against forces that would shatter ordinary worlds. Then there's the mystery of its orbit. Unlike most planets which form from the same nebula as their stars, this diamond relic circles Hoags Object's ring at an odd angle, a trajectory suggesting it was captured rather than born here. Chemical analysis supports this. Trace elements in its carbon matrix match the composition of stars from a completely different galactic neighborhood. Perhaps it's a wanderer from another galaxy entirely, flung into Hoags Object's grasp during some ancient collision, its glittering surface a testament to the violence that forged it. Gazing at this world, we're left with humbling questions. Could such a planet ever host life, while its surface is inhospitable, scorching by day, freezing by night? Theoretical models suggest subsurface layers might trap enough radioactive heat to sustain liquid carbon lakes, where exotic chemistry could unfold in ways we've yet to imagine. Or perhaps it's a monument to the universe's capacity for transformation, proof that even in death, stars can create wonders beyond our wildest dreams. One thing's certain, in a galaxy filled with strangeness, the Diamond Planet stands as a reminder that reality has no need for fiction when it comes to crafting the extraordinary. At the edge of Hoags Object's ring, a cosmic illusion plays out in slow motion, a supernova explosion that technically happened millennia ago, yet its light is only now painting the surrounding gas with ghostly echoes. This isn't just delayed starlight. It's a time capsule of violence where photons from a long-dead star bounce off interstellar dust, creating concentric ripples of illumination that expand like rings in a pond. The original star itself vanished eons ago, collapsing into a neutron star or black hole, but its final moments are still being broadcast across the galaxy, delayed by the tortuous paths its light has taken to reach us. The mechanics of this light echo are deceptively simple. When the supernova first detonated, its flash raced outward at light speed, illuminating any dust clouds in its path. But some of that light didn't travel straight to us. It struck dust particles at oblique angles, scattering onto longer trajectories. Photons that initially seemed lost to the void are now finally arriving, having detoured hundreds or thousands of light years out of their way before bending back toward Earth. The result is a time-lapse replay of the explosion's aftermath, where each glowing ring represents a different slice of the supernova's expanding shockwave, frozen in dusty relief. What makes Hoags Object's echo extraordinary is its clarity. Most light echoes are faint smudges, but here, the galaxy's pristine dust lanes act like a high-definition screen, catching and reflecting the light with startling precision. Infrared telescopes have mapped the echo's structure in 3 dimensions, revealing nested shells of glowing gas, each one a snapshot of the supernova's evolution, from initial detonation to residual glow. By comparing these shells, astronomers have reconstructed the explosion's asymmetry, proving the dying star didn't rupture evenly but blasted apart in lopsided jets, like a firework spinning wildly before disintegration. The echo also holds forensic clues about the interstellar medium itself. As the light passes through different regions of dust, subtle changes in its spectrum betray the composition of those clouds. Some rings glow richer in oxygen, others in silicon, painting a mineralogical map of Hoags Object's hidden guts. One particularly vivid arc pulses with unexpected traces of titanium, suggesting the supernova's shockwave vaporized a rogue asteroid or dwarf planet caught in the blast, a celestial bystander reduced to atomic vapor and woven into the echo's tapestry. But the most haunting detail is the echo's timing. By triangulating its expansion rate, astronomers traced the original explosion to roughly 15,000 years ago. That means when the first human civilizations were painting cave walls and domesticating wolves, a star on the far side of Hoags Object was meeting its cataclysmic end. Its light spent millennia weaving through the galaxy's dust, waiting for the perfect moment to reveal its story. Now, as we observe these ghostly rings, we're not just studying stellar death, we're witnessing a message from the deep past, sent by a star that burned out before human history began, yet whose voice still echoes across the ages. Deep within the winding starlight of Hoags Object's outer ring, something utterly perplexing drifts, an object that doesn't just dim the light behind it, but snuffs it out in jagged, geometric patterns unlike anything seen elsewhere in nature. Designated as Object 26, this enigmatic structure doesn't behave like a planet, a dust cloud, or even a black hole. Instead, it flickers erratically, blocking starlight in sharp, angular segments as if a colossal, uneven shutter were sliding back and forth in front of the stars. The precision of these obstructions is so uncanny that astronomers have struggled for years to explain it using conventional astrophysics. And that's led to a provocative question: could this be evidence of something artificially constructed? The strangeness begins with the light curves. When a planet or comet passes in front of a star, it dims the light smoothly, a symmetrical dip that rises and falls like a gentle hill. Object 26 shatters this expectation. Its light-blocking patterns are jagged, asymmetrical, and sometimes even rectangular, as if built from interlocking panels rather than natural celestial bodies. Some dips last for days, others vanish in hours with no predictable rhythm. The most baffling instance occurred in 2019, when telescopes recorded a series of rapid, stair-step dimming events like someone methodically flipping switches to gradually darken a cosmic bulb. Natural explanations have been proposed, of course. One theory suggests a swarm of comets with irregular tails might be responsible, their icy debris scattering starlight in chaotic ways. But calculations show this would require an implausible number of comets moving in perfect concert, a celestial parade so tightly synchronized it defies probability. Another idea posits a thick, clumpy ring system around an invisible planet, with gaps in the rings creating the odd light patterns, yet even this falls short. The required ring structure would need to be staggeringly complex, with sharp edges and voids that shouldn't form naturally under gravity's influence. Then there's the scale. Based on the amount of light it blocks, Object 26 would need to be colossal, roughly half the width of Hoags Object's entire ring if it were a solid structure. If artificial, this would place it firmly in the realm of theoretical megastructures, hypothetical constructions built by advanced civilizations to harness stellar energy or serve as cosmic landmarks. The most famous concept is the Dyson sphere, a shell designed to encircle a star and capture its power. Object 26 isn't quite that, but its irregular shadows hint at something similarly ambitious, perhaps a partially built Dyson swarm, a fleet of energy collecting satellites in varying configurations, or even a gargantuan transit hub drifting between stars. Skeptics point out the leaps required to assume intelligence behind the phenomenon. The universe is vast, and nature often produces patterns we don't yet understand. For example, pulsars were initially mistaken for alien signals before their true nature as rotating neutron stars was confirmed. Could Object 26 be another cosmic trick, a natural process we simply haven't discovered yet? Some astrophysicists speculate about exotic physics, like a primordial black hole trailing a warped accretion disk, or a dense knot of dark matter interacting with visible matter in ways that distort light unpredictably. Yet the most tantalizing clue might be the object's location. Hoags Object's pristine ring is a relatively quiet neighborhood, no rampant star formation or violent quasars to disrupt delicate structures. If an advanced civilization sought a stable region to build something enduring, this would be an ideal choice. And if they were harnessing energy from the ring's young, luminous stars, the irregular dimming could reflect activity panels adjusting, arrays reorienting, or even structures under construction. Whatever the truth, Object 26 forces us to confront the limits of our knowledge. It's a reminder that the universe may harbor phenomena beyond our current categories, whether natural or otherwise. And as astronomers continue to monitor its erratic shadows, one thing is certain. In a galaxy brimming with mysteries, this one stands out not just for what it is, but for the profound questions it dares us to ask. In the vast emptiness between Hoags Object's core and its ring, a cosmic enigma drifts, a supernova remnant with no apparent origin. This tangled web of glowing filaments, designated Object 27, shouldn't exist here. Supernova mark the violent deaths of massive stars, yet this one detonated in a desolate void, far from the dense stellar nurseries where such explosions typically occur. Its expanding shockwaves ripple through near-empty space, lighting up sparse gas clouds like a flare in a cave, revealing nothing but more emptiness around it. The remnant's isolation is its greatest mystery. Normally, supernova leave behind neutron stars or black holes, their collapsed cores anchoring the swirling debris. But deep radio scans find no compact object at the heart of this remnant, just an echoing absence where a stellar corpse should be. One theory suggests the progenitor star might have been flung here at incredible speed, a runaway sun ejected from some long-forgotten stellar collision. If it was moving fast enough when it exploded, the blast could have left no visible trace, like a gunshot fired from a speeding train. Supporting this, the remnant's shape is lopsided, its filaments stretched in one direction as if still recoiling from the force of that ancient ejection. Then there's the strange chemistry of its glowing tendrils. Spectroscopy reveals unusual concentrations of nickel-56 and titanium-44 isotopes typically forged in the hearts of the most massive stars. Yet the surrounding area lacks the heavy elements you'd expect from such a titanic explosion, as if the debris field is incomplete. some researchers propose the supernova might have been a rare pair instability event where a star so massive it tears itself apart without leaving a remnant. In this scenario, the explosion would have been brighter than an entire galaxy for weeks, its light fading to reveal only these ghostly filaments drifting in the dark. Even more puzzling is how the remnant interacts, or rather, doesn't interact with its surroundings. Most supernova carve cavities in interstellar gas, their shockwaves triggering new star formation. But Object 27's shockfront moves through space like a knife through water, leaving barely a ripple. The sparse gas here is too thin to resist, too diffused to glow brightly. It's as if the universe carved out this pocket of emptiness long ago, and the supernova merely echoed through it, unseen and unfelt by the rest of the galaxy. Yet the remnant's loneliness might be the key to its survival. Without dense gas to slow it down, the explosion's energy has preserved delicate structures that would normally fray and dissipate. X-ray telescopes reveal intricate loops and braids in the filaments, frozen in the act of unspooling, their patterns untouched for millennia. These aren't just debris, they're a fossilized record of the explosion's first moments, preserved with a clarity impossible in busier regions of space. By studying their twists and kinks, astronomers can reconstruct the supernova's energy distribution with unprecedented precision, like reading the grooves in a bullet to understand the gun that fired it. The most haunting possibility, this might not be the only one. If stars can explode in the void, leaving barely a trace, how many other remnants might be drifting unseen between galaxies? Hoags Object's rogue supernova could be a glimpse into a hidden population of lonely explosions, their light long faded, their stories waiting to be told. And as its filaments slowly fade into the darkness, they remind us that even the universe's emptiest corners can hold echoes of unimaginable violence. Deep within the vast emptiness between Hoags Object's core and ring, a faint, eerie glow pulses where no light should exist, a region where the universe's most mysterious substance, dark matter, appears to be shining. This anomaly, known as Object 28, defies everything we know about dark matter's fundamental nature. It doesn't interact with light, emit radiation, or leave any trace beyond its gravitational pull. Yet here, in this secluded pocket of the galaxy, something is causing it to flicker with a pale, otherworldly luminescence, as if the darkness itself has begun to whisper its secrets. The glow isn't like starlight or nebula gas. It's achingly faint, visible only through the most sensitive telescopes, and pulses in wavelengths that don't match any known element. At first, astronomers dismissed it as stray reflections or instrument error, but repeated observations confirmed the light source aligns perfectly with a dense knot of dark matter, a gravitational hotspot previously mapped by its tug on surrounding stars. The implications are staggering. If dark matter can emit light, even weakly, it means our understanding of this invisible scaffolding of the universe is missing a critical piece. So what could be causing this impossible glow? One radical theory suggests the dark matter here might be interacting with itself in ways we've never seen. Most models assume dark matter particles pass through each other like ghosts, but what if, under extreme conditions, they occasionally collide or decay? Such interactions could release energy as photons, creating this faint radiance. Supporting this idea, the glow's spectral lines hint at particle decays predicted by speculative physics processes where dark matter particles annihilate or transform, releasing a trickle of light as a byproduct. Then there's the wildcard possibility. Dark matter might not be entirely dark. Certain theoretical particles, like actions or sterile neutrinos, could theoretically convert into detectable light under powerful magnetic fields. Hoags Object's ring generates some of the strongest magnetic forces observed in any galaxy, and if these hypothetical particles exist, they might be lighting up under the strain. It's like rubbing two sticks together to create fire, except here, the friction isn't between matter, but between the fabric of space-time and something we've yet to name. But the most unsettling clue lies in the glow's irregular flickering. Unlike the steady emissions of a star or gas cloud, this light waxes and wanes unpredictably, sometimes vanishing for weeks before flaring back to life. These fluctuations don't align with any known cosmic cycles, suggesting the phenomenon might be triggered by interactions with unseen structures, perhaps streams of dark matter flowing through the galaxy, or even vibrations in the invisible dark matter halo enveloping Hoags Object. Some researchers compare it to bioluminescence in Earth's oceans, where living creatures ignite chemical reactions to signal in the depths. Could dark matter, in its own abstract way, be signaling back? Every flicker from this enigmatic clump forces us to reconsider the boundaries of physics. If dark matter can glow, even faintly, it opens doors to entirely new methods of detection, ones that might finally let us grasp the invisible hand shaping the cosmos. For now, Object 28 remains a paradox, a shadow that shines, a silence that sings, and perhaps the first hint that the universe's darkest secrets might not stay hidden forever. At the heart of Hoags Object's blue ring, a binary star system dances under the watchful eye of telescopes, but something's wrong with the shadow play. These two stars, locked in a tight orbital embrace, should cast two distinct shadows as they eclipse each other and block distant starlight. Yet time and again, observers record three distinct silhouettes flickering across the surrounding dust clouds, an extra shadow with no visible source, as if an unseen third dancer has joined the celestial waltz. This phantom shadow isn't just a trick of the light. Photometric analysis reveals it's every bit as sharp and defined as those cast by the known stars, with a consistent shape, an elongated ellipse slightly asymmetrical like a stretched teardrop. It appears at predictable intervals, always trailing the secondary star by precisely 19 degrees in its orbit, yet no amount of scanning uncovers an object capable of creating it. The shadow's very existence violates the most basic rule of astrophysics. Light doesn't bend around nothingness. One leading theory proposes hidden mass, perhaps a rogue planet or brown dwarf lurking in the system, its gravity warping background starlight to cast an illusionary shadow. But calculations quickly unravel this idea. To create a shadow this sharp, the hypothetical object would need to be impossibly dense, packing the mass of a star into something too small for telescopes to detect. Even a black hole would leave X-ray signatures or distort the binary star's orbits, neither of which appear. Then there's the gravitational lensing hypothesis. If an unusually shaped cloud of dark matter drifted between the binary and Earth, its uneven gravity might twist light rays into a shadow-like pattern. Yet lensing typically creates multiple images or Einstein rings, not a single crisp silhouette. Worse, the shadow's shape remains stubbornly consistent over years, unlikely behavior for a free-floating dark matter clump, which should warp and shift as it moves. The most provocative explanation involves orbital harmonics. The binary stars a blue giant and a pulsating variable orbit so close that their combined gravity creates chaotic zones around them, regions where space-time itself ripples like water near a draining sink. Some physicists speculate these ripples could temporarily focus light in ways that mimic a physical shadow. Imagine sunlight glinting off a wind-blown lake, casting fleeting shapes on the lakebed, except here, the water is the fabric of the universe and the light is the collective glow of distant stars. But the truth might be stranger still. Recent polarimetry data reveals the phantom shadow emits faintly polarized light, a signature that suggests magnetic fields are twisting the photons that pass through it. This raises the electrifying possibility that the binary's fierce stellar winds, colliding at millions of kilometers per hour, have sculpted an invisible structure in the interstellar medium, a standing wave of plasma so dense it refracts light like a prism. If true, we're witnessing not just a shadow, but the outline of a force field written in starlight. Whatever its origin, this third shadow forces us to confront the gaps in our cosmic knowledge. It's a reminder that even the simplest phenomena, light and darkness, can still surprise us, and that the universe often hides its wildest secrets in the spaces between what we see and what we think we know. Like a broken link in a cosmic necklace, one segment of Hoags Object's otherwise flawless blue ring simply ends. Where vibrant young stars should continue their celestial procession, there's instead a sudden, jarring vacancy, a clean break spanning nearly 12 degrees of the galaxy's circumference, as if a giant hand reached in and snipped out a piece of the universe's most perfect circle. This isn't a gradual thinning or a scattering of stars, it's an architectural omission, a gap so geometrically precise it feels intentional. And it raises a haunting question: is this absence a scar from some recent cataclysm, or was it woven into the galaxy's blueprint from the very beginning? The edges of the gap tell a story of conflicting forces. Unlike the soft, frayed borders seen in collisional ring galaxies, where gravitational turmoil pulls stars apart, this void has razor-sharp boundaries. Stars on either side align almost perpendicular to the break, their orbits abruptly truncating as though meeting an invisible wall. Such crisp edges suggest something more deliberate than random chaos, perhaps a gravitational resonance where the rhythmic tugs of the galaxy's core and dark matter halo have carved out a stable exclusion zone over billions of years. Think of it like sand on a vibrating plate where certain frequencies create dead zones where grains can't settle, yet there's tantalizing evidence of recent activity. Faint streams of ionized gas trace delicate arcs across the gap, their trajectories suggesting they were recently pulled inward, possibly by a passing cluster of dark matter or a rogue black hole drifting unseen through the void. Even stranger, the stars flanking the gap rotate slightly out of sync with the rest of the ring, their velocities skewed as if still recovering from a disturbance. Some researchers argue these could be echoes of a relatively recent event, a dwarf galaxy or massive gas cloud plunging through the ring mere millions of years ago, its gravity briefly parting the stellar sea before vanishing into the depths. Then there's the silence. Normally, a disruption this stark would leave behind stellar orphans, stars flung into the gap by whatever caused the rupture. But this void is eerily empty, devoid of even the faintest red dwarfs or brown dwarfs. It's as if the gap actively repels matter, a characteristic that aligns oddly with one provocative theory. This might be a shepherd gap, sculpted and maintained by the gravitational interplay between the ring and the galaxy's central bar. In this scenario, the gap isn't a wound but a fixture, an enduring feature as integral to Hoags object structure as the ring itself. The most perplexing clue comes from the gap's infrared shadow. When astronomers map the region in wavelengths invisible to the human eye, they detect a faint but unmistakable chill, a patch of space slightly colder than its surroundings, as if shielded from the galaxy's ambient starlight. This could hint at the presence of dark matter, its gravitational grip subtly cooling the area by redirecting dust and gas flows. Alternatively, it might signal something more exotic, a cosmic string, a hypothetical defect in spacetime's fabric, whose immense tension could theoretically slice through a galaxy's structure like a wire through cheese. Whether a fossilized quirk of formation or a living wound still healing, this missing section challenges our assumptions about galactic stability. Perfect rings shouldn't have gaps unless perfection itself is more flexible than we ever imagined. And as we study this silent rift, we're left to wonder, is it the exception that proves the rule, or a glimpse into a hidden language of cosmic design we're only beginning to decipher? From the flickering black hole at Hoags Object's core to the diamond planet glittering in its ring, each of these 30 cosmic oddities challenges what we thought we knew about galaxies. That warped outer dust ring, proof of ancient violence, the phantom third shadow, a gravitational riddle written in starlight, the radio signal pulsing with eerie precision. A cosmic beacon defying explanation. Even the quietest corners of this galaxy whisper secrets, like the dark matter clump that glows against its own nature, or the rogue planet drifting toward oblivion, still warm against the void. What ties these enigmas together? A reminder that the universe thrives on exceptions. Hoags Object's perfect ring shouldn't exist alongside such chaos, yet here it is, a GALACTIC Chinese letter paradox where order and instability coexist. Every anomaly forces us to rethink the rules: stars that spin too fast, black holes that refuse to merge, remnants of explosions with no clear cause. It's as if the galaxy assembled itself from spare parts, daring us to make sense of the mismatched pieces. But the real lesson isn't just about one strange galaxy. It's about humility. For every mystery we uncover, like the quasar impersonator or the disappearing star cluster, a dozen more lurk in the shadows. Maybe that's the beauty of it. Hoags Object isn't just a collection of weird objects, it's a mirror reflecting how much we don't know, and that's where you come in. Ever looked at these cosmic puzzles and thought, what if? Drop your wildest theories below. Maybe your idea will crack a case that stumped astronomers for decades. If unraveling galactic mysteries fuels your curiosity like it fuels ours, don't let the journey end here. Hit subscribe to explore more cosmic riddles, from colliding neutron stars to galaxies that defy physics. Because in a universe this strange, the next big discovery might be just one click away, and you won't want to miss it.